Good morning, kiddos. Today we're going to be talking about 1.6c, and we're going to be going over some of the new terms that we learned in this 1.6 chapter. Okay? So the first word that we talked a lot about was the word congruent. Okay? So when angles are congruent, they have the same degree measure. Okay? When two angles are congruent, they're going to have strikes to prove it. Okay, and those strikes are just little semicircles right near the vertex. If two angles are congruent, then they might have an angle bisector. Remember, the angle bisector cuts the angle in half. And I'm going to draw some strikes to show that these two angles are congruent. And if we have two congruent angles, we can set them equal to each other to solve for a variable. So I could just say angle 1 equal to angle 2, so we can set these up. So if an angle is congruent, they have the same degree measure. They are equal, they are the same, they are congruent. We notate the congruency with strike marks. They could be two different angles. It might be because of an angle bisector cutting the angle in half. In that case, we still have those strikes. And if they are congruent, you can set two angles equal to each other. Next thing that we talked about was supplementary angles. Okay? When we have supplementary angles, we know that these angles add to 180 degrees. We know that supplementary angles form a straight angle, and a straight angle is 180 degrees. It just looks like a straight line. And finally, if two angles are supplementary angles, they also have the name of a linear pair. Just two angles that form a line. Remember, we said that yesterday, a pair of angles that form a line. So if we have supplementary angles, they're angles that add up to 180 degrees. They form a straight angle, which is just a straight line, and they are also known as a linear pair. The last word that we're going to talk about is complementary angles. Okay? And complementary angles, those angles add up to 90 degrees, okay? Meaning that when two angles add up to 90 degrees, that they form a right angle. And those usually look like this, with a box instead of a strike near the vertex to show that this is a 90-degree angle. Now that we've talked about those words again, let's go ahead and do some examples. Okay, so for the first example, we have an angle that looks like this, the ray right in the middle. This side's 1, this side's 2. We know that 2 is 54 degrees. So the first thing they're asking us is, what is the angle relationship? Okay, so let's look at the three words that we just talked about, all right? So first we talked about congruent angles, all right? So this looks to be around 90 degrees, all right? So if these two angles were congruent, meaning that these were both 54 degrees, if we add those together, then this whole angle would be 108 degrees, which this is too small for. If it was 108 degrees, it'd have to be a little wider. Okay? These can also not be supplementary angles because supplementary angles form a straight line, and this obviously forms an angle. Okay? And that leaves us with complementary angles. Okay? This looks to be around 90 degrees, so let's treat it as if it's going to be 90 degrees for this problem. So I'm going to say these are complementary angles. Okay? So now let's go ahead and set this up like an angle addition postulate. Step 1, we're going to set up, okay? So we have angle 1 plus angle 2. I just got these from the numbers that are right here. is equal to 90 degrees because that's what complementary angles equal. Okay, and we know that angle 2 is 54 degrees. So let's plug in for step 2, substitute. We're going to plug in 54 degrees for angle 2. It's equal to 90. Okay, and to get angle 1 alone, since we're adding 54, we're going to have to subtract 54 once on each side of the equal sign. Add 54 minus 54, those cancel, leaving us with just an angle 1 on this side. And then 90 minus 54 is going to give us 36 degrees. Okay, so angle 1 is 36 degrees, angle 2 is 54 degrees, and if we add those two together, we get 90 degrees, which are complementary angles, so that's great. Okay, so let's move on to our next example. Okay, so first thing we're going to have to do is classify the angles. So looking at those three terms that we started with, these could be congruent angles, which there are no tick marks. These could be supplementary angles, because this is a straight line, okay? And straight lines form supplementary angles. So I'm going to say that these are a supplementary pair or a linear pair. Okay? So let's set this up like an angle addition postulate. First thing we're going to have to do is set up. Okay, so I'm going to say angle QRT, side, vertex, side, plus angle TRS, side, vertex, side, is equal to 180 degrees because that's what a supplementary angle is. Okay? So now we're going to plug in what we know. All right, so we know that there's some yucky algebra pieces here, so let's go ahead and plug those in. Angle QRT, side, vertex, side, this first one is going to be 3x plus 5. And then angle TRS, side, vertex, side, is 10x minus 7. And that's still equal to 180 degrees. Okay? So right now we're going to ignore the equals 180 degrees and we're just going to combine like terms on this left side of the equation. Okay? So I see two x terms, okay, or two variable terms, and since they're both positive, we can just add those together. So we have 3x and 10x. 3 plus 10 gives us 13, and that x just hangs on. Then I see two constant terms. Okay, since 5 is positive and 7 is negative, and 7's the bigger number, and it's negative, that means our answer is going to be negative. If you have $5, but you spend 7, now you owe $2 more, okay? So we have a negative 2, and now we're gonna bring back that equals 180. All right? So now we can solve this just like an algebra problem. We have to solve PEMDAS backwards. So I see some subtraction here, but we know how to get rid of that. To undo subtraction, we're going to have to add the 2 on both sides of the equation. Minus 2 plus 2, those cancel, leaving us with just a 13x on this side. And 180 plus 2 gives us 182. Okay, so we're still not done here. We have some multiplication between our coefficient and our variable. So we're going to have to divide to get rid of that multiplication, okay? So multiply by 13, divide by 13, those cancel, so we're just left with a 1x. And then 182 divided by 13 gives us 14. All right, so x is equal to 14. All right, and for our last example, let's think about which one of the so let's think about which terms that we talked about in the beginning, these would match, okay? We know they're not supplementary angles because they do not form a straight line. We know that they are not complementary angles because they are not on the same angle. So let's go ahead and classify these angles, okay? Remember, we learned this the other day. We have vertical angles. And if vertical angles, so like right here between my wrist and my elbow on both sides, they are congruent because they are vertical angles. And that's exactly what we have here. So we have some congruent angles because they are vertical. Okay? And remember that in congruent angles, we can set them equal because they have the same degree measure. So since we're trying to solve for x here, we can set these two equal to each other. So we have 4x minus 11 is equal to 2x minus 1. Okay? I hate negative variables. So I want all my x terms on one side, and I want to move the smaller one so I don't have any negative variables. So I'm going to move this 2x, okay? So I'm looking at the right side of the equation. I want to move this 2x. Since it's positive, we're going to subtract the 2x once on each side of the equal sign. Positive 2x minus 2x, those cancel, leaving us with just a negative 1 on the right side of the equal sign. And then 4x minus 2x, that leaves us with a 2x, and then we're just going to carry down this negative 11 because we haven't touched it yet. Okay, so we got all our x's on one side. Now I want all of our constant terms on one side. Okay, so I see this negative 11 chilling with our variables here. So I want to go ahead and move that. Since it is a negative, we're going to add the 11 once on each side of the equal sign. Minus 11 plus 11, those cancel, just leaving us with a 2x on this side. And negative 1 plus 11, I owe you $1, I pay you back 10. So now I paid you $10 too many, okay? So since there's some multiplication going on between our coefficient and our variable, our 2 and our x, to get rid of that, we're going to divide both sides by our coefficient of 2. Multiply by 2, divide by 2, those cancel. So we are just left with our positive 1x. And then 10 divided by 2 is